All right, let's take a look at 5a. So we're given this graph of the derivative of g. We're told that g is continuous, the original function g, not this one, but it's continuous, and that g of 2 is equal to 5. And the graph of the piecewise linear function, derivative of g up here, is shown from -3 to 7. So this is a common type question that you may see on the free response. Part A asks us to find the x-coordinate of all the points of inflection of the graph of y equals g of x, so not this graph, but the original graph, on the interval from -3 to 7, and we need to justify our answer. So we have to back up our answer after we figure it out. So first step, we need to figure out what do we know about inflection points? How do we figure out when those occur? Just in general, forget this problem, but just what have you learned? Hopefully you've learned something from me about inflection points. All right, you need to be more specific, especially when you do the justification. Can't use the word it. What's it? Second derivative. That's what he meant. All right, so inflection points occur when the second derivative, so we'll write it in terms of g this time, second derivative of g must change from positive to negative or negative to positive. That's actually what we're going to end up using to justify our answer, and it's also what we use to kind of figure out the answer. Second derivative of g must change from positive to negative or negative to positive. That's how an inflection point occurs, or how we know that an inflection point occurs. So we have the graph of the first derivative. Second derivative would be the derivative of that. So really we're focusing on the slope of this graph. Right? The slope of this graph gives us the derivative of g, or second derivative. All right, so second derivative of g equals the slope of the derivative graph. So we don't need exact slopes, but this slope right here is positive. This slope right here, positive. This slope is negative. And then we have another positive slope. So at what points do the slope of this graph, or the second derivative, change? 1 and 4, right? Those are the x values. It's asking us for the x coordinates of the points of inflection. So for part A, G has inflection points at x equals 1 and x equals 4. That's not enough because it asks us to justify our answer. So, like I said, we'll use this because the second derivative of g changes from positive to negative or negative to positive at these points.